right, this video is over inverse relations. So inverse relations notation is the inverse of a relation r is written as r to the power of -1. To find the inverse of a relation, you switch the x and y values. A one-to-one relationship is a function has a one-to-one relationship if the relation and its inverse are functions. Okay, so think back to what we talked about at the beginning of the year. If something is a function, it means that the x values do not repeat. Okay, so an example here, they gave us a relation here, and the inverse of that, all you do are just switch the x and the y values. So our inverse would be -2, 1, 4, 2, -1, 3, -2, 4. Okay, so then you decide, is the relation a function? Well, looking at the x values, none of them repeat, so yes, it is a function. Is the inverse a function? Okay, well, the -2's right here repeat, so that makes it not a function, so you say no. Is the relation one-to-one? It is not one-to-one because the inverse is not a function, so no. So both of these have to be yeses in order for this to be a yes. Okay, so on the next one, so just reverse these. So we have 5, 1, 6, 1, -4, 3, and 9, 4. Is the relation a function? It is not a function because the ones repeat. Is the inverse relation a function? Yes, because none of those repeat. Is the relation one-to-one? No, because the original relation was not a function. Okay, on number 3. Okay, now remember that these are points 0, 6, 1, 2, and 11, 6. Okay, that's what those lines and those arrows there mean. Okay, so the inverse of this would be 6, 0, 2, 1, and 6, 11. Is the relation a function? The original one is yes. Is the inverse a function? No, because the 6's repeat right there. Is it one-to-one? No, because the inverse was not a function. Okay. All right, the horizontal line test. So it says, recall, the vertical line test is used to determine whether a relation is a function given a graph. The horizontal line test is used to determine whether the inverse of a relation is a function. Both the relation and its inverse must be a function in order to be a one-to-one function. Okay, so first you want to do the vertical line test. Okay, so that's where you run your pencil. Does it hit the graph more than 1 point? No, so it is a function for the original relation is a function. Then you try the horizontal line test. So you go this way. Does it hit your pencil at more than 1 point? No. So it passes both the vertical and the horizontal line test, so it is going to be a one-to-one function. So you just say yes. Okay, on number 5, vertical line test, it passes. Horizontal line test, it fails, because if you were to draw a line right here, it's going to hit this point, and this point. So no, it is not one-to-one. Okay, so flip over to the other side. Now let's talk about inverse functions. So it says notation, the inverse of a function f of x is written as f to the power of -1 x. To find the inverse of a function, step 1, you replace f of x with y. Step 2, interchange x and y. Step 3, solve for y. Step 4, rewrite y as f to the power of -1 x. Okay, so the first thing you want to do is you want to say y equals 5x. Now we're going to switch these two. So x equals 5y. Now we're solving for y. So to do that, we divide both sides by 5. So we have y equals 1/5 x. The final thing is replace this with the inverse part. So f to the power of -1 x equals 1/5 x. And that's your answer. Okay, this one, so y equals x minus 7. Switch these two. X equals y minus 7. solve for y. So add 7 over. So we have y equals x plus 7. Replace this with this. So we have f to the power of negative 1 x equals x plus 7. Okay, number 8, y equals x minus 8 over 3. Switch those two. X equals y minus 8 over 3. To solve for y, first you have to get rid of the denominator. So you want to multiply both sides by 3. Okay, so we have 3x equals y minus 8. Now, to get y by itself, you want to add 8 over. So y equals 3x plus 8. So the inverse function is 3x plus 8. Okay, number 9, y equals negative 2/5 x plus 1. Switch those two. X equals negative 2/5 y plus 1. To solve for y, first you want to subtract 1 over. So you have x minus 1 equals negative 2/5 y. To get y by itself, you've got to multiply by the reciprocal here, and the reciprocal is negative 5 over 2. Okay, so we have y equals. Over here, we've got to distribute this negative 5 over 2 into the parentheses. So negative 5 over 2 times x is negative 5 over 2x. Negative 5 over 2 times negative 1 is a positive 5 over 2. And then replace that with the inverse function. Okay, all right, this next one. There's an extra little part to it because of this. First, we're going to do this part. So we have y equals x squared minus 9. Then we switch those. X equals y squared minus 9. Okay, so then we want to solve for y. So first you've got to add 9 over. So we have x plus 9 equals y squared. To cancel the squared, you want to take the square root of both sides. So we have y equals the square root of x plus 9. Okay, so that is the inverse function of the square root of x plus 9. Okay, now because it says we are only looking for when x is greater than or equal to 0. So what you have to do is you have to take what's underneath the radical here, set it equal to 0, and solve this. And so it turns into x plus 9 equals 0. You have to subtract 9 over. So that turns into x. We're only looking at the values when x is greater than or equal to negative 9. Okay, you only have to do that when they've included this part on there. Okay, number 11. So we have y equals x plus 4 to the power of 3 minus 6. So switch those, so it turns into x equals y plus 4 to the power of 3 minus 6. So first thing, you want to add 6 over. So you have x plus 6 equals y plus 4 to the power of 3. To cancel out to the power of 3, we're going to take the cubed root of both sides. Okay, so we have the cubed root of x plus 6 equals y plus 4. Then we've got to subtract 4 over. So you have y equals the cubed root of x plus 6, and then we have minus 4. And that's the inverse function. Cubed root of x plus 6, and then minus 4. All right, verifying inverses using compositions. So it says two functions f and g are inverse functions if and only if f of g of x equals x and g of f of x equals x. Okay, so we talked about composition functions not that long ago. You just turned in a worksheet over it. So you have to check for both of them. So first we've got to plug this in for the x value here, and we want to see if it's going to cancel out to equal x. Then we have to do the same thing by plugging this in for the x value here and see if that cancels out to equal x. Okay, so where this x value is, we're going to put a parentheses, and we're going to write the square root of x minus 8. Okay, and then we still have squared and then plus 8. Okay, on the other one, where this x value is, we're going to plug in this one. So we have a parentheses, we have x squared plus 8, and then we have plus 8. Oh, I'm sorry, minus 8. Sorry, that's minus right there. Minus 8. Okay, so we want to check both of these and see if they're going to cancel each other out to equal x. Okay, so on this one right here, the square root and squared cancel each other out, so we're left with x minus 8 plus 8. The negative 8 and plus 8 cancel, so we are left with x. On this one, okay, these parentheses do not make a difference. So the 8 and negative 8 are going to cancel. And we have x, the square root of x squared. Well, the square root and squared cancel each other out, and so that equals x. So because these both simplify down to equal x, then that means that they are inverses of each other. So you can say, yes, they are inverses. Okay, on the next one, same thing. So where this x value is, we're going to plug in this whole thing. So negative 4, parentheses, x over 4 minus 5. And then we have plus 5. Okay, so then you do the same thing on this other side. So where this x value is, you plug in this one. So negative 4x plus 5, it's over 4, and then minus 5. Okay, so first let's simplify this one down. So we're distributing this negative 4 in. So when you distribute negative 4 times this, okay, well, that turns into negative x, because negative 4 times 1/4 is basically what that is. Or you can say negative 4 times x is negative 4x, and then divided by 4 is negative x. You can say it like that too. And then negative 4 times negative 5 is a positive 20. So then that equals negative x plus 25. Does that equal an x? No. Since it does not equal x, you don't even have to worry about that one, because we automatically know that they're not going to be inverses. So you can say no, not inverses. And that's your answer. Okay. All right, let's look at the graphing part. All right, so it says graphing inverses. So given triangle ABC is formed by the points in the relation -1, 6, -7, 2, and -5, -3, what is the inverse of this relation? Well, first, you just switch those to find the inverse. So it's 6, -1, 2, -7, -3, -5. Okay, so we want to graph both of these triangles. So first, let's graph the original one, which is -1, 6, -7, 2, -5, -3. Okay, so this is the original relation, and then the inverse of that is 6, -1, 2, -7, -3, -5. Okay, so it says graph triangle ABC and its inverse. We did that. What do you notice about the graph? Okay, well, if you notice right here, they're a reflection of each other, but what are they reflected across? Well, if you turn your paper kind of like this, you can actually see it a little better, and they're actually reflected across the line y equals x. Okay, so I'm going to draw that line dotted right here so you can see it better. But they're reflected across this line right there. Okay, so reflected across y equals x. And that's always going to happen with inverses. They will always be reflected across that line of y equals x. Okay, that's how you can verify that they are inverses of each other. All right, so let's do a few examples of this. So it says, find the inverse of each function, then graph both functions and verify the inverse relationship on the graph. Okay, well first, let's go ahead and graph this original line right here. So 2x plus 8 has a y-intercept of 8. So go up to 8 on the y-axis. So 1, 2, 3, 4, 5, 6, 7, 8. And then a slope of 2 over 1. So up 2 to the right 1. And we just keep repeating that to finish out the line. We're going to go down 2 to the left 1 as well. Okay, so this is our line right here. I'm also going to draw the line y equals x. I'm going to draw it as a dotted line. That's what we want our line to be reflected over. Okay, so that's just going up 1 to the right 1. It just keeps repeating that. Okay, so this is our line that we want to be reflected over. Now to find out what the inverse is, we're doing like what we did on the other note sheet. So replace this with a y. So if y equals 2x plus 8, switch these. So you have x equals 2y plus 8. Then solve for y. So subtract 8 over. So x minus 8 equals 2y. Divide by 2. So y equals 1/2 x minus 4. And that's the inverse that we need to graph. Okay, so our y-intercept here is -4. So 1, 2, 3, 4. And a slope of 1/2, so up 1 over 2. Okay, so it's going to look like this. And notice that they are inverses. And if you want to turn this to where this line is straight up and down so you can see it better, that's fine, but they are inverses of each other because it's a reflection. Okay, all right, let's look at the next one. So we have 1/3 x minus 1. So let's graph that. So it has a y-intercept of -1 and a slope of 1 over 3. So up 1 to the right 3. Okay, so then you want to connect your points to create a line. Okay, I am going to also go ahead and draw my y equals x line, which is going to be like this. Okay, so then let's find the inverse of this. So we have y equals 1/3 x minus 1. Switch these, so we have x equals 1/3 y minus 1. Solve for y, so we'll add 1 over. So we have x plus 1 equals 1/3 y. You want to divide here, but you can't divide by fraction, so instead we multiply by the reciprocal, which is 3. So we have y equals 3x plus 3. So the inverse function is 3x plus 3. So that has a y-intercept of 3 and a slope of 3 over 1. So up 3 to the right 1. Okay, and notice that they are a reflection, so they are inverses. All right, let's look at this last one here. Okay, so notice they only want us to graph from when x is greater than or equal to 0. So we're starting to get these points. If you want to type that in on your y equals on your calculator to get them, that's fine. And so we're going to start at 0, -4. And then we have a point at 2, 0. And a point at 3, 1, 2, 3, 4, 5, around 3, 5. Right here. So it's going to look something like this. Okay, let me draw my dotted line for the inverse. Okay, all right, so this one, so it's going to be y equals x squared minus 4. So we have x equals y squared minus 4. Let's solve for y, so we're going to add 4 over. So x plus 4 equals y squared. Take the square root of both sides. We have y equals the square root of x plus 4, which is the inverse of square root of x plus 4. Okay, so type that in on your calculator to be able to find out where it starts, because we have this x is greater than or equal to 0. We want to take what's underneath the radical, set it equal to 0, and then solve. And so that's -4. So we have x is greater than or equal to -4 is what we want to be. That's where we want to start our graph at. So 1, 2, 3, 4. So at -4 here starts at -4, 0, and then we have a point at 0, 2, and then at 1, 2, 3, 4, 5, around 5, 3. It's gonna look something like that. Oops, I should go straight. Something like this, okay? So notice the reason why we have to do this part is because if we were to keep going, well, first of all, with a radical function, you're not gonna have anything less than the x-axis right here. It's not gonna go past that endpoint. And so that's why whenever it's a quadratic, we can only do part of it to show that they are inverses of each other. So that's the reason why we do the domain and stuff like that. Okay, so this is the graphing inverses. So this is inverse relations and functions.